Okay, so time to do a bit of a review of right angled trigonometry. If you think back, we have our three main trigonometric functions that we're working with: sine, cosine, and tangent. Now, we established that we have sine of theta is equal to opposite over hypotenuse. I've just shortened that to O and H. Cosine of theta is equal to adjacent and hypotenuse. I've just shortened the adjacent to A. And tan of theta is equal to opposite over adjacent. Now remember, this is a review of right angled trig, so we would have learnt a way to remember it, which is known as Sohcahtoa. Okay, I write Sohcahtoa this particular way because it displays the O over the H, much like what we have with our trigonometric ratios up here. The thing that we have to remember is that this only works for right angled triangles. Okay? We cannot use this in triangles that are non-right angled. Alright, we must remember that. It only works for right angled triangles. So, why don't we get stuck into it and try to use this to find some information out about triangles. Our first question says, to find the unknown side in the triangle. In this particular example, we're going to end up with the variable, in this case the x, in the numerator. I've already drawn a triangle here with 27 degrees. 15 meters on the hypotenuse. We know how to find that because it is opposite the right angle, and it's also the longest side in the triangle. Okay, so what we want to look at here at the moment is we want to find where our angle is to begin with, and then where our sides are in relation to that angle. So you notice here, in relation to 27 degrees, our x is opposite that angle. Across the triangle, it is opposite. So we're going to label that with an O. You'll notice here, our other piece of information that we're given here in this diagram is the length of the hypotenuse, which is 15 meters. So we can straight away label that as the hypotenuse. We only have two pieces of information here, an opposite and a hypotenuse. If we come back up here, right, using Sohcahtoa, the only one that has opposite and hypotenuse in it is sine of theta. Okay? So we have sine of theta is equal to opposite over hypotenuse. Okay, now we're going to take this equation and we are going to try and fill in some of the information. Okay, so we know our theta here, in this particular case, would be 27 degrees. Okay, theta, when we're talking about it in trigonometry, just means our angle. Alright, and that's going to be equal to our opposite side, which over here is x. We don't know what that is yet. Okay, over our hypotenuse, which is 15 meters. Now, just like when we're solving normal equations, we need to find some way to get this x by itself. In this particular case, this fraction symbol here means divide. So we need to do the inverse operation, the opposite, okay, which is times by 15 to clear it off. And what we do to one side, we do to both to keep our equation balanced. Okay, these 15s are going to cancel. So we're now left with our new line being x is equal to 15 times sine 27 degrees. What we can do now is that we can enter this in on the calculator, and I suggest you do that. I'm going to calculate this to 2 decimal places, which means that I am going to end up with x is equal to 6.81 meters to 2 decimal places. Now it's really important that we write the 2 decimal places there. Okay? And that is how we find an unknown side in a triangle with a variable in the numerator. Okay? The next example that we're going to work with will have the variable in the denominator. I'm going to show you 2 different ways to solve this, and one of them will be longer to show you how we get through everything, and the other one will be a little bit of a shortcut that you can take once you know how the long way works. Okay? So just like the last question, we're trying to find an unknown side here in this triangle, x. Now already we know that x is on the hypotenuse. Okay, we're going to label that h because it's opposite the right angle in the triangle. The other information that we have, looking at our reference angle here, which is 32 degrees, okay, is that adjacent to it, next to it, that's what adjacent means, is 22 meters. Okay, it's not opposite the triangle over here, the angle over there. So what we need to do now is just put it into our equations that we're working. So we go back to Sohcahtoa. Okay, we know that the only one that has adjacent and hypotenuse is cos. So cos of theta is equal to adjacent over hypotenuse. Just like last time, we're just going to fill in the information from our triangle. So cos of theta in this particular case is 32 degrees, is equal to our adjacent, which is 22, over our hypotenuse, which is x. Now you'll notice immediately here that the variable is in the denominator. Okay? So the long method, which is what I'm going to show you right now, okay, requires us to get x out of the denominator. Okay? To do that, what I need to do is I need to get rid of this division symbol. Alright? So what I'm going to do is I'm going to multiply both sides by x. What I do to one side, I do to the other. Just like last time, the x will cancel like the 15, and we end up with a new equation. X times cos of 32 degrees is just equal to 22. Okay? Now I'm just being very careful with writing the x and the time sign because it can get a little bit tricky if your handwriting isn't neat. Now, just like solving an equation, we need to get this x by itself. Alright? In between the x and the cos of 32 degrees is a times. So we do the opposite. Okay? We divide both sides by cos of 32 degrees. Okay? And all that does is it allows us to cancel out the cos on this side and leave us with just x on the left hand side is equal to 22 over cos 32 degrees. So you notice already that this is a little bit of a different approach to what we did when the variable was in the numerator. Now all this requires us to do is to whack this in on the calculator. We're going to end up with, let me just move this up here so you can see what's going on, and you're going to end up with x is equal to 25.94 meters. Again, that's just 2 decimal places. Okay? Now, this here, this particular section here, is the long method. Okay? So why don't we try and establish a pattern that's coming out throughout this method of solution. You notice in our original equation, we started off with cos of 32 degrees is equal to 22 over x. Let's just come down here and write that. So cos of 32 degrees is equal to 22 over x. Okay. However, once we move throughout this equation, eventually the x and the cos of 32 switched places, didn't they? So what you can do when you're solving a trigonometric ratio question with a variable in the denominator, once you get to this step and you've established this equation, you can take all of this stuff out in the middle and jump to the answer. Okay? So if we look down here at the shorter form of the equation, essentially these two are just going to swap. So you end up with the equation being x is equal to 22 over cos of 32 degrees, which we know that is equal to 25.94 meters, 2 decimal places. Okay? That's just a shorter method of attempting these types of questions if you wanted to cut out a few steps. But here's why it works. Okay? That's just a shorter method of how you get it to work. Okay?